advanced technology works and how its practical use does wonders for the handicapped.
A visit to the West Lake in early spring is always a great time, especially for me, if I could have a moment here. This is how human history was once remembered, carved into the stone to endure the test of time. Taking a walk along this most respected institution for stone carving and seal graving by the tranquil Xihu Lake showed how humans etched their lives with creative hands. Less than 1 hour's drive from this place, a new piece of virtuosity and harmony is crafted with a lifelike artificial intelligence-aided bionic hand. It's controlled via wearer's brain waves and muscle signals with the use of brain-computer interface techniques and the latest AI tools. Dr. Hanbi Cheng is a pioneer in the field of brain-computer interface, or BCI. From a Harvard researcher to a promising entrepreneur, he tells me what he's always wanted to do is to make a super sensor that can analyze signals from the brain within infinite energy, then understanding the brain's intentions and turn them into reliable tools to help those in need.
These are some of our representative robotic hand products. Robotic hands have very complicated structures and components, so making a good robotic hand is not easy. We have made over a dozen generations of them. This is the original one, so it looks relatively simple and is made of steel.
Quite cute, though.
Yes. Then we made this, which looks good. But we overlooked the important role of fingers, so the fingers turned out to be short. In later generations, we improved the fingers, and that brings us to this robotic hand, which has many main motors installed under the fingers to give it a stronger grip and better flexibility. A few years later, we presented this one, which is consistent with the functions of real human hands.
With the proliferations of LLMs, large language models, and the rapid development in AI, what does that mean to what you are doing, the brain and computer interface?
For the past decade, we've been working on a big tech challenge, that is, using a focused approach to collect and decode neural signals from the human body. AI has been a key tool in this process. As AI advances rapidly, the tools we use are improving, but the fundamental challenge remains: the complexity of the brain. With 86 to 100 billion neurons and countless neural connections, we still need to understand what these signals represent and how we can use them to create meaningful products. That's the key problem we're trying to solve.
The first EEG appeared in 1920s, so it's about 100 years ago. Now, with AI's rapid development, how much is it going to speed up our understanding of how the brain works and how the brain would work for us once we need it?
Dr. Hans Berger discovered brainwaves in 1924. Now we are at a pivotal moment. We're entering the second century of brain research. But what happened over the past 100 years? Many scientific fields advanced together, leading to the exponential growth of brain-computer interface technology. This field combines multiple disciplines. We need material science to develop sensors that can accurately detect neural signals. We need neuroscience experts to understand how the brain works. And we need an AI computing specialist to decode these signals. If we truly want to decode the brain, the only way is to turn it into a real product that solves real-world problems. When we can produce thousands of devices, run large-scale trials with hospitals and universities, and gather massive amounts of data, then we can really start to unlock the brain's secrets. That's why our path is to build real products, collect data from real users, and keep improving along the way.
Yes, indeed, you have already customized.
Sure.
So what have you discovered by now? Because your products appeared quite a few years ago already, despite of the fact it has been renewed by generations. So throughout the past years, what have all those big data that you have collected meant to you about what you have discovered about the brain-machine interface?
我们关注这个技术。
Technology itself isn't the biggest focus. The people are. In other words, we care more about understanding this group of people than just improving the tech. Over the past few years, I've spent a lot of time with people who lost their hands or legs. I measured their neural signals, but I also observed their daily lives. I've personally visited over 100 of their homes, just to understand how they live. Because only when we truly understand. For example, when we first designed prosthetic hands for women, we made them look like Iron Man's hand. That's because our initial research was done in the US, and many people there liked that design. But later, we found that many women in China didn't want a hand that looks like a machine. They preferred something that matched human skin tones. Even though they needed the hand for daily tasks, they would cover it with gloves or something to make it less noticeable. Another thing that surprised me was how people without hands live. If you check the official data in China, there are a lot of people with limb disabilities. But you rarely see them in daily life. That's because many of them just stay at home. They don't want to go out. They feel uncomfortable and inconvenient without hands or legs. That's why our main goal is to help them leave their homes, get back to normal life, and reconnect with society. And this is extremely difficult. Why? Because people lose their hands or legs for so many reasons. Illness, birth defects, explosions, burns, and the condition of their remaining muscles and nerves varies a lot. On top of that, after they get a prosthetic hand, they face thousands of different situations in daily life. Designing a hand or leg that works well for all of that is far more difficult than running a controlled lab experiment. So, as we move into real product development and real-world use, we realize that instead of focusing only on technology, we need to focus on understanding these people. Our team has set a very clear goal. In the next 5 to 10 years, we want to help 1 million people with limb loss. We want to give them prosthetic hands and legs, help them regain daily functions, and return to society. That's our biggest mission. So far, we fitted a few thousand people with our first-generation products.
Over the years, Dr. Han Bicheng and his team hold dear to the spirit of early-stage entrepreneurship, simplicity, and down-to-earth. This is one of their working spaces. It could hardly match anyone's imagination of a cutting-edge institution. Really, nothing fancy, and yet very efficient. Non-invasive kinds of interaction, machine-brain interaction interface. There is also another track which is invasive. For example, 1 year after you established BrainCo, Elon Musk established Neuralink. That is invasive approach. How would you compare these two different approaches?
首先，我觉得侵入式和非侵入式。
First of all, I think both invasive and non-invasive research are very important. They follow different paths and solve different problems. When I first got into brain-computer interfaces, I had the chance to observe a few invasive experiments. During surgery, I realized something. The human skull is really hard. Opening the skull is actually quite scary, at least for me. They have to use a tool like a saw to drill a hole about the size of a coin before the procedure can begin. I believe this technology is very useful, but it's mainly for severe conditions, like blindness, Parkinson's, owls, or severe paralysis. This technology could help people with severe conditions recover. But what I'm interested in is helping a much larger group of people, those living with autism, depression, Alzheimer's, sleep disorders, or limb loss. I want to find solutions for them. Back in 2015, after some independent thinking and deep research, I realized brain-computer interfaces could lead to a huge company and a whole new big industry. Here's a simple fact. About 30% of all healthcare spending is related to the brain and nervous system. But to this day, we still don't have any truly effective treatments for many brain disorders. For example, is there a drug that can cure autism? Or Alzheimer's? Or completely treat depression? No, and there are many reasons for that. One important reason is the blood-brain barrier. The blood-brain barrier is a protective layer that blocks harmful substances in the blood from entering the brain. But it also blocks many drugs, making brain disease treatments much harder to develop. That's why many scientists have started to shift toward other solutions, like brain-computer interfaces. For us, it's all about helping people, and we believe this technology could be a key to treating many brain disorders.
If you had the opportunity to talk to Mr. Musk, what would you like to interact with him about or discuss with him about?
我可能会想了解更多。
I'd probably want to know more about his thinking. He had so many options in different fields to work on, but he chose brain-computer interfaces. From what we can see now, he's focusing on two things: helping blind patients and people with severe paralysis. I'd like to understand why brain diseases interest him so much, and what his next plans are. I don't think his answers would change our direction, because we already have a very clear product roadmap. We'll keep moving forward along that path. But I'm really curious why, out of all industries, he also chose brain-computer interfaces.
So here's something I'm really curious. It's kind of a two-way question. On the one hand, AI is a tool that helps you find solutions faster and better, like you said. But on the other hand, it feels like there's some kinds of competition between human brains and AI. What is your take on that? Especially since you work directly with brain-machine interfaces, you probably have a unique perspective than most of us.
其实我觉得马斯克做这家公司的初衷，其实基本上能回答您的这个
Actually,
问题。
I think Elon Musk's original intent for starting Neuralink already answers your question. In the beginning, he said he created the company because he was worried about AI. He believed AI would eventually surpass humans. So he wanted to build something that merges human and machine, a kind of interface that lets humans hold their own competitive edge when AI becomes smarter. But for us, our focus is different. Our main goal is to decode neural signals and create real products that make a real difference. We're not obsessed with AI itself. For us, AI is just a useful tool to make decoding more efficient. For example, right now we're very interested in a particular type of signal, timing signals in children with autism. Many kids with autism avoid contact or don't like talking to people. There's a very complex reason behind that. One interesting theory connects to something we all experience. For example, when someone yawns in a meeting, others start yawning too. But why does that happen? One theory says it's because of something called mirror neurons in the brain. These mirror neurons are linked to our subconscious ability to mimic others. So when you see someone yawn, you automatically want to yawn too. This kind of mimicry actually played an important role in evolution. It helped people bond and form groups. But for children with autism, this ability is much weaker. They don't naturally copy others. When they see someone talking to them, they often want to avoid eye contact or turn away. That's why we're now studying whether we can help by regulating mirror neurons. If we could stimulate them properly, maybe these children would feel more comfortable talking to others. Right now, we're especially focused on a type of brainwave called the mu wave, which is closely related to mirror neurons. If we can regulate these brainwaves, it might help kids with autism become more willing to communicate and interact. That's one of the key things we're working on.
How do you see the relationship, competition, and the cooperation?
其实我们根本就不 care 这个竞争。
Honestly, we don't really care about competition. I think we're all working towards solving a huge shared problem. For those of us doing R&D, every day is exciting because we're seeing things we couldn't see before. But like I said, what we care about most is the people who've lost hands or legs, people who struggle with insomnia. And there are so many people with insomnia in China. Statistics show that about 30% of adults have some degree of insomnia. And then there's depression, autism, and Alzheimer's. All these are brain-related conditions. But for these groups, very few problems have been truly solved. The technology we have or the technology we're developing might actually help solve these problems. If the technology we're working on can help improve their lives, then all the years we spent studying and doing research will be worth it. That's what matters to us most. It's why we started this in the first place. In fact, if another company comes along and solves these problems faster and better, I'd welcome that. These issues are so complex. It takes many people working together to make progress. So far, I think Musk's team has done a great job, and they've made fast progress. If they can help blind people see again, or help paralyzed patients and ALS patients, that's incredibly important. Those people need every breakthrough we can get.
Seeing is believing. While quite overwhelmed by Dr. Han's grand goals, I decided to try with my own eyes and my own hands how exactly the latest BCI technologies roll out real benefits. It can detect my neural and muscle signals and identify with my motion intentions, translate these motion intentions through these systems into the actions of these bionic hands. This can detect my neural and muscle actions. Now I'm looking at the computer screen, they're really learning. Oh, see the number is ever rising, huh? Yeah, it's identifying. Oh, really going up, 100% it's already learned. So now I can close or open my fist. See? It goes with me. See, here's my hand and my bionic hands. Wow, that's fun. Just as I was also in the showroom, who are doing their daily battery of tests are a few members of Dr. Han's team. They all have to do the heavy lifting, weighing in on the latest technologies against end user needs.
So this is also the only hand in the whole world that can play piano, because you used to move individual fingers to do that.
Well, 1 year only already so good. I'm very confident about the future.
Yeah. Actually, after he learned it, we keep updating the AI algorithm in there, and more people can practice, can play piano using the same algorithm. Yeah.
So we should high five, right?
Yeah, high five. Yeah.
Amazing. So how long have you practiced?
More than 2 years.
So this is the only prosthetic hand in the whole world right now that can move individual fingers. That allows him to hold the pen very steady, and when he writes, the pen will stay there and he can control it freely.
Amazing. You can still, you go with the strokes like this and can still practice this side, huh? Wow, I like it. Really firm handshake.
Yeah.
I know you want to show me the legs, but I don't know which one.
It's very hard to tell.
Can you tell though?
Yeah, because I know. But if I don't know, I probably cannot tell either.
Really?
Yeah, he's one of our users, and he's an amputee, and one of the leg is the prosthetic leg.
Okay.
Yeah.
So
but when he
guess.
walks, it's very hard to tell.
It's so hard to tell.
Yeah.
It just looked like someone who just off the basketball court.
Yeah, it's very
kind
natural.
of exhausted.
Yeah.
Left?
是右边。
It's right leg.
You got
chance. See, I told you.
Yeah.
I got another chance. Okay. So can you make maybe is it hard for you to walk with this?
不困难，
It's
特别
not
方便。
difficult to use. It's so convenient. It is easy for me to walk with this leg.
我拿过我们
I've won
我们
many
国内很多
fitness
的一些
competitions in
健身大
China.
赛的冠军。
Bodybuilding. He's actually
Amazing.
he can show you the muscle if you want.
I love this, you know. With you as my guide, I can just linger around your showroom for the whole day.
There's a lot of interesting stuff to show.
Oh, absolutely. And they are amazing.
Oh yeah, I love them.
Yeah,
They are like best friends here.
So they are part of the team, right?
Yes. They are a full-time employee of the company. They are actually part of the research team.
Oh,
So
yeah.
they help the R&D team. They give them a lot of real experience, first-hand experience of how the products. They, a lot of feedbacks they can give and a lot of advices and suggestions for improvement, for updates, for upgrades. So they are actually deeply involved in the R&D process.
While they are sitting there, I see the hands are still moving, huh?
The way they control it, just like we control our hands.
Yeah. The technologies are changing so fast. How to think about these possibilities with everybody's help?
We actually have a very lean team, very lean staffed R&D team, but they are all very smart and very efficient. So we always come together and we have this shared mission. We want to use the technology to help those people who needed the most help. And everybody, we work very closely together, all the engineers and the neuroscience and all the technicians, and they know the technology can change their lives. So we all work towards the same direction. So everybody know that this thing will change the whole society. So everybody is, work very closely and collaborative. And also we all come from, the school together. So we're a team since then for a long time. And it's very collegial environment. And all the collaborations are the teamwork are very smooth.
But now you're different. I mean, you're becoming the center of the attention for China and even the world in a way. So how is that, transforming your relationship with one another?
We have been devoted into this area because we believe the possibility of this technology. So whether the public notice us or not, we'll do the same thing. So I think for the funding team and also for our R&D people, what really matters is they have this belief in this technology.
And what matters to them is actually what the technology means for their real life.
Yes, the social impact it can bring in real world.
Life changed, huh?
它至少是
It is, at least, enough for life's necessities while letting me pick up calligraphy, which I've always wanted to practice since childhood.
以前出门会
In the past,
刻意的会去
I would
遮掩。
deliberately make myself scarce when going out to avoid unnecessary trouble. But now with this hand, I can confidently step outside. When people notice me, I even introduce it to them. It gives me a sense of
They're
pride.
very proud of it.
I really also wonder, what does it mean for you, work with all different kinds of team members?
For my job right now, I'm in charge of all the external relations of the company. I think what I enjoy the most is I share my belief to other people. So I share my values and I share my vision for this technology, for the the future, the potential for the social change and with other people. So I think I really enjoyed it very much. And the team itself is a very small team, as I mentioned. We only have a little bit over 200 people globally, and we work seamlessly together. And among the 200, less than 250, we have 8 amputees work with us. And they are part of the team, and we work very closely together.
Right.
And I think what we do is not only developing the technology, we also help those people who cannot afford it now, can actually have this technology.
Almost every one of your team members, those that are involved in the research, are returnees. In a way,
yeah,
they
a lot of
studied
them.
overseas, a
Right,
lot of
right,
them, right?
right,
Including you and also the founder.
Yeah.
So it's different from some of the local companies.
The whole environment here, especially for startups, is very good. It's like spectacular, and the government has been very supportive. And we have a lot of people around us, especially in this area. We actually have gathered a lot of young people, so we have a lot of communication. We encourage each other, and they're very lively. The whole city is very young, and we can feel the incentives of everybody and the energy of everybody.
Feel at home.
Yeah, feel at home, definitely. Yeah.
Thank you so much.
Thank you.
I really enjoyed it.
Thank you.
I think I went to Harvard driven by curiosity. Later, at Harvard, I also met people who had lost their hands or legs. That's when we thought this technology should first help the people who need it most. Our team is still small. We can only focus on so much. Our first priority has always been helping people with disabilities. And now that we've actually launched products and gotten real feedback, we see just how much these people need them. For example, last year in Zhejiang, we fitted prosthetic legs for over 300 people. When we followed up, we found that many of them had started going out again, and most importantly, many of them found jobs and began building new lives.
Some of them even joined your team, right?
Yes, we've hired quite a few of them.
You started your entrepreneurship originally in the US. It was a garage entrepreneurship. And then you came back to China, stayed in Shenzhen for a few years, and then move on also with offices in Hangzhou and elsewhere. What do you make of this track and the choices that you have made?
首先我在美国是工作和学习。
I worked and studied in the US, but as a Chinese, I always knew I would come back, just like many other international students from China. And the product we're making requires very advanced manufacturing and production processes. So when we reached the stage where we could turn the technology into a real product, the first thing that came to mind was bringing it back to China for production and further development. First, China has an advanced manufacturing ecosystem with high-precision instruments and a strong supply chain. Second, once the technology was ready, we wanted to start by helping people in China, fitting prosthetics, and helping them regain their daily lives.
But now, your products are also helping people around the world, right?
That's right. Brain disorders and limb loss are global challenges. So now our products are also back in the US, where we've started production and sales there too.
From data to computational power and to some other categories of resources, what do you think is needed the most for you?
我觉得对于我们来讲，最需要的是对人体
For
本
us,
身
the most important thing is understanding the human body's neural signals. Human brain is incredibly complex, and honestly, we still know very little about it.
So what you're saying is that we are basically still at the foot of the Himalayas?
I'd say we're at the start of a Cambrian explosion. After 100 years, key technologies have finally come together, and now we're seeing a wave of new applications. Most of these applications are about relieving human sufferings.
A few hours with Dr. Han and his team have been an unforgettable experience for me. But taking a walk in this well-known innovation park in Hangzhou, I noticed that they are not the only ones here. It's such an exciting trip to the Brain Hole, but they are not the only one here. In fact, there are many other budding entrepreneurs here riding on the latest trends of cutting-edge technologies and innovation. They are working very hard to deliver for the potential of AI for good. After all, it is the people that technologies should serve, not the other way around.